Good morning. I'm sorry we had technical problems this morning on Blackboard with my microphone. It was not set right, so had to cancel the session after 15 minutes of trying. So instead of being able to go through Blackboard, what I've done is I'm solving the problems that we were supposed to do separately, and I'm posting them as YouTube videos. So you would see it exactly the way that I would do it on Blackboard. The only difference is you can't ask any questions, and if you have any questions after you see the videos, feel free to send me email or ask me on Tuesday. Okay. So the first problem that I had planned on working this morning was page 277, question 7. And this is a problem involving the uniform continuous distribution. So the context that we have here is that you are bidding on a piece of land, and any bid that you make in excess of $10,000 will be accepted. But you're up against a competitor, and what the data tells us, the narrative in the problem tells us, is that the competitor's bid, is uniformly distributed between $10,000 and $15,000. So basically what this narrative is telling us is that the competitor will bid somewhere between $10,000 and $15,000, but you don't know how likely any of those values are. So it's a continuous uniform distribution. So because of that ignorance, you are assuming that he's equally likely to bid anywhere between $10,000 and $15,000. Okay. So the first problem says that suppose you bid, your bid is $12,000. So I'll just write 12, okay, to $12,000. And it asks, what is the likelihood that your bid will be accepted? Your bid will be accepted if your competitor bids less than you, isn't it? So you see the graph on the left-hand side, that uniform distribution is what the competitor is going to bid. So you will win if your competitor bids less than $12,000. Okay. So in terms of our areas, this is how, if you recall, we did it in class. So we have so the competitor is bidding $12,000. Rather, if the competitor bids less than $12,000, then you win because you bid 12,000. And so what is the probability of that? Probability of any uniform continuous distribution is the shaded area, actually, which in this case is base multiplied by height. So the height of this rectangle is equal to 1 divided by 15 minus 10. Okay, because the base of the full rectangle, we know that the area of the full rectangle is 1. That's a property any continuous distribution has to obey. But since the full area is 1, the height has to be 1 divided by the base, which is 15 minus 10. Okay, so the likelihood that the competitor will bid less than $12,000 is base multiplied by the height. Base multiplied by the height, which is equal to 12 minus 10, which is the base, multiplied by the height, which is 1 divided by 15 minus 10, which is equal to 2 divided by 5, is 40%. Okay, so that's part A. So we are going to do the other parts in a similar way. The part B says, suppose you bid 14,000. What is the probability that your bid will be accepted? Again, you draw a little picture. So here's the competitor's bid, can be anywhere from 14 to 15. If you bid $14,000, which is here, let's say roughly, then you will win if your competitor bids less than 14. Okay, so what is the probability that the competitor bids less than 14? This is again equal to base multiplied by the height. The base is 14 minus 10. By the way, it always helps to shade the area that you're trying to compute. The probability that x is less than 14 is the area that I just shaded, which is base multiplied by the height, and the height is 1 divided by 15 minus 10. So this is equal to 4 divided by 5 is 80%. Okay. And then part C says how much should you bid to maximize the probability that you will get the property, that you'll be sure to get the probability. Okay, get the property rather. So you can see that if you bid 15,000, okay, then the probability that you win, so if you again draw this little picture over here, 10 and 15, the likelihood that your competitor will bid less than 15 is equal to base multiplied by the height, which is 15 minus 10, that's the base, and the height is 1 divided by 15 minus 10, which is 1. And intuitively that makes sense. If your competitor is going to bid somewhere between 10 and 15, nothing outside that range, okay, then if you bid $15,000, then you're guaranteed to win. Okay, so and those are the answers to the first three parts, and that's those three parts are fairly easy. It's the last part, D, so I'll draw it on a fresh page. Part D, that's a little bit involved. So again, you have the competitor here bidding anywhere from $10,000 to $15,000. Okay, and it says suppose you know someone who's willing to pay you $16,000. Okay, so you can get $16,000 if you win and sell the property. Okay, so so you have a buyer in hand, and that buyer is willing to pay you $16,000 for the property, but you first have to win it in against your competitor. Okay, so the question says how much should you be willing to bid, okay, in order to maximize your profit. So how much should you bid? So in part C, if you looked at part A, B, and C, I think, let me go to that sheet. If you look at parts A, B, and C, the calculations told us that if I bid $12,000, the likelihood that I win is 40%. If I bid $14,000, the likelihood that I win is 80%. And if I bid $15,000, the likelihood that I win is 100%. Okay. But now if I think of profit, that is, suppose I win and then I sell, I can sell for 16,000. Okay, so should I still bid $15,000? Because $15,000 guarantees me that I'm going to win the property. But should I really be bidding $15,000 if I have a customer who's willing to pay me $16,000? Okay, so let's look at the analysis here. So let's start with the obvious one. Let's say you bid $15,000. You are sure to win. Probability of winning. You're sure to win. So if that happens, how much profit do you make? Your profit that you make is $1,000, isn't it? Because you will sell it for 16, you just bought it for 15, and you're absolutely certain. So you made a profit with a probability of 1. You can make $1,000 profit absolutely certain. Okay, but suppose I bid a little bit less. Suppose I bid $14,000. Then from my previous calculation, I know that I'm not absolutely certain to win it. There is a 80% chance that I will win. That's what we saw in part part B, I think. But look at the advantage. The profit that you make is $2,000. Okay, so if you win, it's not guaranteed, but you'll make $2,000 profit. Okay, so if once I have these two numbers, let's see what is the expected profit. I am absolutely certain that I can make $1,000 profit. Okay, so in the second case, what is the expected profit? It's the profit multiplied by how likely it is to make that profit, which is 1.6k. Okay, so this calculation, obviously I'm not going to make $1,600. I either make $1,000 or $2,000 or $3,000, but the expected profit calculation that we just did allows us to make comparisons as to what I should bid. Okay, so suppose I bid $13,000, then the likelihood of winning, let's see, the likelihood of winning, we'll see what the calculation would be. I think it turns out to 0.6 actually. Okay, but I would make $3,000 profit because I can turn around and sell it for 16k, so I made a $3,000 profit. So the expected profit is 1.8 thousand, so $1,800. Now suppose if I drop down a little bit more, so in part A we calculated that if I bid $12,000, the likelihood that I win is 0.4, but then I could turn around and sell it for $4,000. Okay, so the expected profit is 4,000 times 0.4 is $1,600. Now do you see that the expected profit went up, so up, and went down. Okay, so based on this analysis, what I should bid is $13,000. That maximizes my expected profit. Okay, so this is what now if you're a very risk averse person, then you might say, hey, I prefer to make a bid of $15,000 because I'm guaranteed $1,000. But there is a model in economics called rational expectations. So if you are to compare these different bids, economists would tell you that you should bid $13,000 because your expected profit is higher, meaning you're not absolutely certain of winning, but if you do win, you'll make that much more, $3,000 profit you would make. So how do you compare an absolutely certain outcome, which is the first one, against the other uncertain outcomes? And the way to do that is using expected profit. That allows you to compare. And so the answer to part B was I should make a bid of $13,000. Okay.